Welcome to Lesson 4, where we will efficiently add integers and other rational numbers. Now, the main outcome of this lesson would be for all of you to understand the rules for adding rational numbers. Okay, this idea of adding rational numbers. We will begin. In Lesson 5, we will work on subtraction. Now, we'll talk more about subtraction later on, but for now, we are going to try to finalize this idea of adding rational numbers. Okay, so let's go ahead and work through this example 1 together. Okay, and again, a lot of this seems real simplistic. It does to me. It may to you as well, but again, it's a lot of the terminology we are learning that is real important. So, okay, so example 1 asks you to represent the sum of 3 plus 5 using arrows on the number line. Okay, so the actual problem we're doing here is this: 3 plus 5 equals 8. Okay, so 3, of course, is an arrow vector to the right, 3 units, okay? And then if we add 5, we just carry on from there with another arrow, another 5 units, okay? So that's what my arrows on the number line look like for 3 plus 5 equals 8. Now, some questions follow here. So, and again, seem pretty obvious, but they are trying to make a point. So, number 1 asks you, how long is the arrow that represents 3? Okay, and of course it is 3 units, and there they are: 1, 2, 3. 3 units. Okay, so we're going to put units right now because we don't exactly know what unit of measurement it is, but we'll call them units. And what direction does it point? And it points on our number line here to the right. If it were a vertical number line, it would point up. Okay, so we could point /up if that were the case. And this is this idea of a positive move, and that is always to the right. Okay. Now, in number 3, how long is the arrow that represents 5? And of course, this makes sense that it is 5 units. Okay, 5 units. All right, and finally, what is the sum? Well, actually, there is one other question between that I seem to have cut off. And what does that ask? It says, in what direction does it point? And that's the one that comes after this. That's number 4. And of course, that's to the right as well. This would be the answer to number 4 there, okay? And of course it points to the right because it is a positive move. All right, and then what is the sum? Sum, of course, is 8. And we know what the sum is because that's where the second arrow, or our Q, ends up. Okay, that's where it ends up, at 8. So if you were to represent the sum using an arrow, so that means represent this number here, the sum 8, how long would the arrow be, and what direction would it point? Okay, so if we look over here, if we were to represent the sum as an arrow, that arrow would look like this, okay, because that is the sum. Now this sum right here also has a length, and that length, of course, is 8 units. Okay, 8 units to the right. Okay. Okay, so what is the relationship between the arrow representing the number on the number line and the absolute value of the number? Okay. Now, this arrow representing the number we look at it, here it is right here. Okay? And the absolute value of that number. Now that absolute value of that length of arrow is the absolute value of that number. So this is 8 units long. Therefore, its absolute value is 8 as well. Okay? Its absolute value. And the reason we talk about absolute value now is because if this arrow were to be here, is that right? Hold on a second. One more. You can see that that arrow is also 8 units long. So 1, 2, 3, 4, 6, 7, 8. Okay, 8 units long. And it also has an absolute value of 8 as well. Okay. All right. So we can say here the length of arrow is equal, or I should just go ahead and put an equal sign, equals the absolute value. Okay. All right, so there, see it's in little number 8 there, it says, do you think that adding 2 positive numbers will always give you a greater positive number? And, of course, why is the question. And, of course, we know the answer is yes. We've known that for quite some time now in our lives. But as to the why about it, they are primarily because the absolute values are positive. So the sum will be a greater positive. On a number line, adding them would move you further away from 0 to the right or above on a number line. Okay, so as you move further away from 0, now we're talking about, of course, positive numbers now. Okay, these you will get a continually larger positive number. Because again, I'm just going to use this one for now because we are talking about positive, so our positive realm is over here. Okay, so as we add those, add 6 plus 4, for example, okay, 2 positive numbers, all right? Those absolute values are compiling, they're adding up. Okay. All right, so here we go. We have B. This is our example 1, part B. And what they're asking us to do here is to represent the sum -3 plus -5. Okay, again, we are talking about a sum, and we know it's a sum because of our plus sign there in the middle. Okay, but now you'll notice that we have negative numbers. Okay, so it's a little bit different. Before we were using positive numbers, the same numbers, but they were positive. It was 3, if you remember, 3 plus 5. Okay, now we have -3 plus -5. Okay, so let's go ahead and do that. Again, we're going to start from 0 because we have nothing to start out with. Okay, so we're going to make a move of -3, and that is 3 units to the left because our negative sign points us that way. The -5, we'll start where we ended up, and we will end up at where we end up. So we have a -3 plus a -5. Okay, and again, really, really, really important when we really solidify our understanding of adding rational numbers, or in this case, we're adding positive and negative integers. Just because it is plus does not mean a number will get bigger. Okay, when they're positives, we saw that. Okay, when there are two positive numbers, okay, adding two positive numbers, they will give a greater positive number. Okay. In this case, we are looking at two negative numbers. All right. So let's go ahead and answer the questions that come below. So how long is the arrow that represents -3? And again, it is 3 units. It's not -3 units. It's 3 units. Very, very important. Okay? What direction does it point? Now here's what determines or deems it positive or negative. In this case, negative. Okay? It's to the left. All right? How long is the arrow that represents -5? Again, it is 5 units. It's not -5 units, but it is 5 units to the left. And that's the next answer to the next question there, is what direction does it point? Okay, so we're looking at using the same numbers here, but we are going the absolute opposite direction. Okay, and let's see if I missed one here. So yeah, it looks like I missed that number 5. And I put the number 5 in there. And that number 5 asks us, what is the sum? And of course, now if we look, our sum is -8. Sum is -8. And that is where we end up when we add or find the sum of -3 and -5, two negative numbers. Okay. Now, really important, what ties these two problems together, A and B. If you were to represent the sum using an arrow, how long would the arrow be, and what direction would it point? Okay, so if we do that, if we just start from here, one arrow, there's our sum, which is -8. You will notice, just like this one was 8 units long, this one is also 8 units long, okay? But now we know it's 8 units long, pointing to the left. So to the left. And that direction is important. So, number 7 here, do you think that adding two negative numbers will always give you a smaller negative number? Okay. Now, really important there in terms of this word here, which is again something that throws kids off. It's this idea of a smaller negative number. Okay, as we know, when we add two positive numbers, we are always going to end up with a larger positive number. Okay, as we saw, 3 plus 5 equals 8. Okay? Now with a negative, with the opposite of a greater positive is a smaller negative. Now, smaller in what sense? Smaller in its value. Okay? And on a number line, numbers get smaller as you move to the left. As you move to the left. And here's the thing. This could trip you up. You may say no to that because you're thinking, hey, as I move to the left, the number is getting bigger. The look of the number. Here's 3, here's 4, here's 5, here's 6, here's 7, here's 8, here's 9, here's 10. Okay, I see that number here, the number looks like it's getting bigger. But the truth is, its value is getting smaller. -10 is less than -1. Okay? It is less. You are further and further into debt, into the negative space. Think of temperature, okay? Temperatures that go from 0 down into the negatives, temperatures are getting lower. The temperature is lower as you go down the scale, down the thermometer. And again, this way too, we look at a thermometer this way. Here's 0, and I'm thinking of Celsius. 0 degrees is freezing. As we go down, negative whatever, negative 10 here, okay, temperature is going down. So if you think about negative numbers in those terms, maybe in terms of temperature, something that we have experience with, that could be very helpful. So do you think that adding 2 negative numbers will always give you a smaller negative number? And that is, the answer is yes. Okay, that number will get smaller. If you want to think of, instead of saying smaller negative number, you could say smaller negative value, maybe. Okay, or think in terms of temperature. Okay, and again, the key is to the left. Numbers get smaller as you move to the left. They get larger as you move to the right. Okay. And C here, it says, what do both examples have in common? Well, if you notice the length, I think I erased it. Oh no, I didn't. Here we go. Here's the length of our sums arrow here, and there's the length of the other sums arrow. And if you notice that, you will notice that they both have the same length. Okay, so both sums have same length arrow, which means they have the same, and you know it, absolute value. In terms of distance from 0, they are exactly the same. And let me just use this one here just to illustrate here. If we move positively, we've got a positive sum of positive 8. And then if we move the other way, we have a sum of negative 8. These are the same length,